Hello and welcome back to another Chainlink Hackathon workshop. We've got another fantastic workshop ready for everybody here. We're talking about upgrades again. Hello, welcome. I was going to say hello and welcome, and it turned out to be welcome. Hello and welcome to the chat. Hello and welcome to the workshop. I see a couple people in the comments section. I will be monitoring comments, so please ask questions. Please ask as many questions as you would like. Today, like I said, we're going to be going over upgrades and upgrading our smart contracts and making our smart contracts more flexible and not interchangeable, more flexible in the future, so we can add different changes. We can have our functionality do different things as we progress and that type of thing. So, got a couple people in the comment section. Like I said, feel free to ask questions. This is a little bit more advanced. This is definitely a little bit more advanced section. However, it can give you the tools to be incredibly flexible. And if you combine this with our DAO section, with our governance section, you can really build incredibly powerful smart contract and hybrid smart contract applications that can be governed, right? That can have this flexibility, that can change depending on what the consent of the governed want. So with that being said, we're actually just going to jump right into the code, and we are going to explain what we're doing as we go along here. So if I pull up the code here, actually, let me pull up the full example of what we're going to be doing here. Let me pull this up. What we're going to be doing today is we're going to have a contract like this box contract. And what we're going to do is we're going to deploy this box contract, and we're going to say, hey, we forgot to add a function. Oh, and it looks like I need to make this a little bigger. Oh, whoops, sorry. I need to change the size of this one. There we go. Sorry. So we're going to have this box contract, and we're going to, we say, we forgot to add a function in here. Oh my goodness. And in our box v2, we're going to say, this is the contract that we actually wanted to create, right? We actually wanted to have this increment function here that we didn't have on our first deployment. So we're actually going to create a way for us to take this contract, take this deployed contract, and say, we're going to upgrade to this one, right? Now, the question obviously is going to be like, well, how do we do that? How do we do this if these smart contracts are immutable? How can we upgrade our smart contracts? And that's what we're going to be talking about today. And I'm going to be giving you some resources and some links. Here is the full code that we're going to be going over today. And if you're more familiar with hard hat, you're more familiar with JavaScript, be sure to check out the hard hat upgrades video that we did yesterday. I also have a more in-depth video as well on this exact subject. I posted a link to that in the chat too. And one more thing, upgrades, Open Zeppelin state. Open Zeppelin is going to be, we're going to be using a lot of Open Zeppelin contracts once again. They have a fantastic blog on the state of smart contract upgrades, because it's not as simple as, okay, here our contract is now upgradable. There's actually a lot of nuance along with it, right? Like, for example, if you make your smart contract upgradable, is it decentralized still? Well, if one person has the key, it's not really decentralized. Trail of Bits, for example, advocates that people just shouldn't do upgrades, right? Because they make these projects needlessly complex. They add this layer of centrality. They add all these things that these smart contracts don't need to have. People get lazy when they build their smart contracts, when they know they can just upgrade them later, and that type of thing. So there's definitely more than just, okay, cool, I'm going to use this, I'm going to put it in. There's definitely a lot to think about. But in any case, this is what we're going to be doing. And as we upgrade it, we're going to go and show you how we're doing it. Now, the simplest way actually to do an upgradable smart contract is we would just redeploy, right? And that is technically a way to upgrade our smart contracts, right? We could redeploy. We could say, hey, the address that we deployed this originally on, we don't care about anymore. It's this new one is the one that we care about, right? This box v2. Use this box v2, and by social convention, people migrate to this new one, right? So we call that the social migration or the social yeet. This is how we move, we quote unquote upgrade. But we want a more programmatic way to do that, right? Because the thing is, they're going to have two different addresses, and we want it to have one address. So that being said, let's start coding some stuff here. I'm going to move this out to the side. Let's start coding some stuff. So we're going to get started here with Brownie init. And if you're unfamiliar how to work with Brownie, link setup instructions. I'm going to add some Brownie. Add some Brownie Chainlink setup instructions to the chat. You can definitely watch this later. Jump into the Discord, ask questions. If you haven't worked with Brownie before, links are in the description. Again, if you prefer hard hat, we did a video on this exact same subject yesterday. This is actually an interesting question. How long until bank robbers figure out that the digital signatures of 1 to 5 people is worth more than any bank job? Am I too bleak? I don't think you're too bleak. It's actually it's interesting. There's a concept called the wrench attack, right? We're always concerned about flash loan attack, Oracle manipulation attack, but one that we don't talk about a lot is the wrench attack, where somebody hits you with a wrench and takes your private key. But I mean, the advantage of having private keys and such is that you don't have to. It's not like a physical thing, right? If you know your private key and there's no like written down paper or anything, well, never mind. There's a lot of different private key security methods that you can do, and that hypothetically be more safe and more secure. But yeah, I mean, these are obviously things that we want to look out for. We don't want to be. It's really the same as the Web 2 world, right? You don't want to get broken into. You don't want to have your stuff stolen. So I don't think that makes any bigger or smaller security implications. But in any case, let's go ahead and create our first contract. Maybe box.sol. We'll paste it in here. And this is going to be this contract. It's I'm not going to code it live because it's pretty simple here. We just have a box. We have a private value, uint256. We're going to emit an event whenever we change a value. And we have this store function. So we're going to pass a uint256. We're just going to change this value up here. And we have a retrieve function, right? So if I wanted to, deploy this box, normally I could just deploy the box, and be happy with it. And let's go ahead and create our custom deploy script, though, for doing the upgrade here, because it is going to be a little bit different, because we're not just going to deploy the box. We're actually going to deploy a few things. Where can we find full tutorial, like from zero to hero or any bootcamp? Great question, especially for Brownie. So I'm going to give you 2 links here. So I'm going to give you this free code camp video, zero to hero, everything's in there. And then we also do have a couple bootcamp videos, both for hard hat and Brownie. Link is in the description as well. Is a governance DAO needed in order to upgrade smart contracts? No, and this is one of the things you want to keep in mind, right? If you have a governance DAO, that's probably going to be better than just giving one person the keys to upgrading your protocol, right? Because again, if you don't have a DAO, your protocol is centralized again, right? If you can change it, if you were the one who can change everything, it's not really decentralized. So it's not needed, but if you want to make it decentralized, then that's definitely something you want to keep in mind. So in any case, all right, so here we are in our deploy function, and this is where we're actually going to do a lot of the work. Hard Hat has some nice built-in plugins, Brownie, for doing upgrades. Brownie doesn't have them, so we just have to code all of this stuff ourselves, but that's actually really good because we can understand what these proxies are doing a little bit better. So we'll do def main is going to be deploy box, and we'll do, oops, F deploy box. We'll just do pass for now. So it looks good. Okay, cool. So first thing we're going to do in our deploy box, we're going to do account equals get account, or we could do like accounts 0, but I like to do this little get account thing. For those of you who have watched my videos before, I'd like to make this helpful scripts.py folder. I'm going to paste a whole bunch of stuff in here, but don't worry, I'll explain what's going. I like using this get account function. It allows me to easily flip between, a test net and a local development network. So I just return an account. That's all that this get account function is doing. And I'll import it. init.py. Now we'll do from scripts.helpful scripts import get account. We have an account in here. Now we'll do, now we'll deploy the box. Box equals box.deploy. We'll do from account. And if all I wanted to, and then I got to do from Brownie import box. And we'll just do like box.address. Great. So if I just went ahead and ran this, Brownie run scripts, one deploy box on a local network, right? We're going to spin up our ganache here, and we're just going to deploy the box, right? Nothing really particularly interesting. This is going to be our logic contract here. Now, what we're going to do is a little bit more more interesting now. So we have this box deployed, but we're not going to point people to the box here. We're not going to say that this address is the address we want people to go to. What we're going to do instead is we're going to deploy a proxy and also a proxy admin. So the way that this works is we're going to point, when we give people the address of our contract, we point them to this proxy. And this proxy will make the calls to our box contract. So, and this way, when we upgrade, all we do is instead of the box pointing to the proxy pointing to the box, we now have it point to our new box, our box v2, right? So when we upgrade, we say, hey, it's not pointing to box anymore. It's now pointing to box v2. That's exactly how these proxies work. We just change which box contract we want to point to. And the thing that's really cool is that we're going to use some low-level functionality called delegate call. Now, what delegate call does for us for these proxies is allows us to call some functionality in a different contract as if we had that functionality. So if we're the proxy contract and we call the box contract, we can call with delegate call, we can call any of the functionality of box and say, yeah, we have that functionality, right? So we can like borrow the functions, run it in our contract, even though we don't have the functionality, right? So this is incredibly powerful. And this is how we actually store storage variables in the proxy instead of in the box in the implementation, right? So I know that that's a little bit dense. Again, feel free to jump in if this isn't making sense here. So we're going to be using this delegate call so that the proxy is the contract that holds the state. So the proxy runs all these functions. The proxy is the contract that can run store, right? We run store, but on the proxy contract, even though the proxy contract doesn't have this store function. So let's move on. So how are we going to do this? Well, first thing we want to do is deploy a proxy admin. Now, a proxy admin contract is going to help us. Do upgrades on our proxy. So we do have to get these contracts though. So if we go to GitHub, we could make them, right? But if we go to GitHub, open Zeppelin contracts, We go to contracts, proxy, ERC 617 something. This one. This is the proxy. Oh, we need the admin actually. Proxy, transparent, proxy admin. This is the contract that we need, right? This is the contract. This is going to give us those upgrade functionalities for this proxy to work with. So I am just going to copy paste this into our code because we are going to be using a lot of Open Zeppelin stuff in here. So if we go to contracts, I'm actually going to create a new folder called transparent proxy because this is we're actually using the transparent type of proxy. Don't worry what that means for now. And I'm just going to paste this in. Now, obviously, I need these two. These two in here. I'm actually going to grab. I just need to like reroute instead of this from being from local. I just need to reroute it to Open Zeppelin. So I'm just going to just swap this out with @OpenZeppelin/contracts. And then since I'm doing @OpenZeppelin/contracts, I got to go into the Brownie config.yaml. And we're going to create a dependency on Open Zeppelin/Open Zeppelin contracts at I think 4.3.2. It's the most recent, and then we'll do compiler, soak. The mappings at Open Zeppelin equals this. Boom. Cool. Now we can do this. We also need our transparent upgradable proxy. So we can just go back. We can grab this, and we'll do the exact same thing because this is the proxy that is going to be pointing to our box. So we're going to do new file, parent, upgradable proxy.sol. We'll paste it in. Now this line will actually work. If I just make sure to spell it right. Then we can change this. Change this line to @OpenZeppelin/contract/proxy ERC7 blah 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 blah. Okay, cool. And this is still mad. Transparent upgradable proxy.sol. Transparent upgradable proxy.sol. Maybe I spelled it wrong or something. Well, we'll find out later. The deployment of the proxy and the implementation require two different transactions. Not necessarily. Like we could do them all in one transaction, but we're going to do it in two transactions here for simplicity. Great question. Yeah, good question. But you do need to, deploy your implementation and your proxy. So they each do require a deployment. But okay, great. So now we have those contracts in here. Let me just talk about real quickly what they're doing. So this transparent upgradable proxy is the proxy. We don't technically need the proxy admin. The proxy admin is more helpful really than anything, but we do 100% need this. This is the contract that has some upgrade functionality. And I think this upgrade to and call is imported. Yeah. So these upgrade to functions that it has is what it does to reroute, to point to the new implementation, right? So when we deploy our box v2, we use these upgrade functions and it'll point its storage variable to this new deployment, to this new area. So what we can do then for our deployment, first, we'll deploy a proxy admin. So we'll say proxy admin equals, let me just zoom back in. too zoomed in, let me know. We'll say proxy admin.deploy. We'll say from account. Grab proxy admin. Actually, I do want to zoom out a little bit. We'll grab proxy admin from we'll grab proxy admin from our contracts. And great. Now we have proxy admin. Now it's time to add to deploy our upgradable proxy. Now, when we deploy this, if we look at the constructor, see it takes 3 input parameters. Okay. It takes the address logic. This is going to be the address of our implementation contract. This is going to be the box, right? It takes the admin. This is going to be our proxy admin. It could be our, it could be our account. We could 100% make it our account if we wanted to. And then it's going to need some bytes data. Now, this is the data of what's called the initializer function. You'll notice our box doesn't have a constructor. This is by design. If our box has a constructor, this means that we might be storing state variables, or we might be doing something that we can't do. Remember, in these upgradable smart contracts, all state variables and all storage is actually in the proxy and not in the implementation. The implementation, this box contract, is purely for logic, right? This is where all the logic is going to be. But this private value, UNT256 private value, is actually going to be stored in our proxy, right? Because when we call store from the proxy, store, the proxy is going to pretend it has this store function. So it needs to save this value to itself. And so it's going to save some value variable basically to itself in a storage slot. So that's just something that we have to keep in mind. So we can't have these constructors, but we can have what's called initializer functions. And these are functions that you just call, right after you deploy, basically. So we do need to encode our initializer function. So we're going to deploy our transparent proxy, but first we need to encode our initializer function. Now, we don't have an initializer function. Well, we could set store as our initializer function. We are just going to have no initializer here. So what we can do is we can say, initializer equals futils to bytes 0 futils. And this is just basically, the 0 hex string that we're going to give it for our initializer function, our encoded initializer function. Now, in the mix that I sent in the chat, we actually have a function called encode function data that you can use as well. But once we have this, we can do proxy equals transparent upgradable proxy.deploy. Of course, we need to grab this from Brownie. And we'll say box.address. We'll say the box is the logic, right? The proxy admin.address is going to be our admin, and then the data is going to be that initializer function, which for us we're doing a 0, but you could totally encode some initializer function. Right, and then we're going to say from account, and we're also going to give it a gas limit, just because Brownie actually has a little bit of a hard time estimating gas limits for proxies. Right, and then we're going to do print f proxy deployed to proxy. You can now upgrade. What we can do is we can say, I call it proxy box, but you can do whatever you want. Brownie doesn't know that this is a proxy. Brownie thinks that this is a contract and it has all these proxy functionalities. It doesn't know that it has, store, retrieve, these events and everything. So we got to tell Brownie, hey, this is a you can call box stuff on it. So we're going to say contract dot from ABI. I'm going to import contract from Brownie contract dot from ABI. We're going to give the name box. It's going to be at proxy.address. And then we're going to give it the box ABI, right? So basically, we're slapping the box ABI onto the proxy address. And now we can do print, printf proxy box dot re. This should be 0. And this should be 0, of course, because we just initialized it 0. So now if we run this, we should be able to get 0 back with this deployment. Perfect. That's exactly what we get, right? And so we should even be able to do, proxy box.store 1, and then, the tx equals proxy box.store 1, tx.wait 1, and now, or maybe we'll do 77, right? So now if we run this, we should get 77 from our retrieve. Whoops, I need to do from count. I'll try that. Perfect. We do indeed get 77. Now, if I were to run box.retrieve, what do you think I'll get? What do you think I'll get if I run box.retrieve? Box.retrieve, chat. Let me know in the chat. While you think on that, I'm going to answer a couple questions. But yeah, what do we think we'll get if we run box.retrieve? Can you do a one-off upgrade of an upgradable proxy so that the ability to upgrade goes from being centralized to being part of governance DAO? Yes, you absolutely can. Great question. Absolutely 100%. So, and this is part of the reason why I'm showing you how to do it with a proxy admin. So this proxy admin is some smart contract on chain that we've given it to. You could make your proxy admin a DAO, right? So before we showed how to do compound governance, we showed a little bit of using snapshot as well. You could give your upgradable smart contracts to your DAO. You could have them be the admin. Yes, absolutely. Great question. So you would just want to make sure that your user has revoked access, right? So that the only person, the only protocol with access to do upgrades is going to be the DAO. Contract.from ABI, is this a Brownie specific functionality? Deploys a contract from an ABI file? Great question. So this line here, what we're doing, yeah, this is a Brownie specific. What we're doing basically is it doesn't deploy something, but we're creating in Python, we're creating a contract object from an ABI that we give it, right? So we're creating a contract object. We're calling the contract box, and we're basically just sticking the box ABI on the proxy address. So now Brownie, our Python, knows that that proxy box has box functions, right? Because when we deploy proxy, Brownie says, okay, proxy has proxy functions. It has upgrade. It has implementation. It has all these other things. If we were to try to run, proxy.retrieve, Brownie's going to look at the proxy contract and go, there's no retrieve in here. What are you talking about? You can't do that. So we're just going to say, hey, Brownie, at this address, I promise there's a box there. So you can do box calls to it. So hopefully that makes sense. Great question. So it looks like nobody was brave enough to ask about box at address. So there box dot proxy box. Box dot retrieve. Right. So if I were to print box dot retrieve, what do you think this is going to be? Right, proxy box dot retrieve returns 77. What do you think box dot retrieve is going to return? Zero. right? Why does it return 0? Because the state is stored in the proxy box. When we called proxybox.store, remember, it's stealing that store function for itself, and it's running store on the proxy contract, not on the box contract, right? The box contract is just for our logic, and that's how these upgrades work. So, mind closing? Oh, sorry. Yep, thank you. Good call. Thank you. Great. So now what do we do? Okay, so we have the proxy deployed. We have storage uninitialized. Yep, yeah, you got it. Storage uninitialized, which is 0, right? If you Solidity defaults most values, you and 256 get defaulted to 0. So yes, great. So now that we have this thing deployed, let's go ahead and do our upgrade on it. So what we want to do now, we'll create a new file. We'll do O2. We'll call it upgrade. Actually, for this demo, maybe we'll just do it in the same. We'll just do it in the same. For this demo, we're going to do it in the same. For the code that I gave you, they do it in 2 separate scripts. So we're just going to create a new function called def upgrade box. We're just going to call it after we deploy the box. So in our upgrade box, what are we going to do? So same thing, we're going to do account equals get account. And we have our box deployed. We have our proxy deployed. We're going to do box v2 equals box v2 dot deploy. And let me actually give you the box v2 code. Box v2 dot sol. Paste it in here. So it's literally a copy paste of box v1, and I'll even, let's even just copy it from box v1. So it's literally a copy and paste of box v1. We're just going to call it box v2, and we're going to give it one additional function. We're going to give it increment. We're going to say function increment. This will be a public function, and we'll say value equals value plus 1, and we'll emit the value changed. That. So we just have this in here, right? If we were to call increment right now, actually, if I were to do, let's just do pass. If I were to try to call increment right now, right? If I were to do proxy box dot increment from account, what do you think will happen? We run this now. It should break, right? Because that function doesn't exist. Box has no attribute increment. What are you talking about? You're being crazy, right? And then even if we were to put like the ABI of box v2 on it, box v2, say, we could say proxy box v2. Look at that contract from ABI box v2 proxy. Let's say proxy box that address box2.abi. If we were to slap box2 on it and we were to try to run this, we're going to get an error still. It's going to say, well, what you can't do that. There's no function called increment. You're being crazy. Don't be crazy. Be smart. So there's no increment function, right? So now what we're going to do though is we're going to deploy the logic for box v2. We're going to deploy the logic, and now we're going to point the proxy to this new box. So we're going to say proxy equals transparent upgradable proxy -1, and this is just Brownie syntax to say, hey, get us the most recently deployed transparent upgradable proxy. We're going to say proxy admin equals proxy admin, same thing, -1. Excuse me. Give us the most recent proxy admin. And then we're going to call some type of upgrade function. Now, the upgrade functionality is a little bit tricky depending on where you're upgrading from. So in my in our upgrades mix, if you go into scripts, helpful scripts, there's kind of a big function in here called upgrade, and it does a whole lot of stuff. It's really just checking to see, okay, if you have a proxy contract, you do something a little different. If you have an initializer, you do something a little different. Since for this demo, we're just going to call, we're going to make a function called upgrade with the admin. And we're going to pass it an account, proxy, new implementation, and then proxy admin. Okay. And here's and this will be the function that we call. So right on our proxy admin contract, the proxy admin contract has an upgrade function. And all we need to do is pass the proxy.address. So the proxy admin points to our proxy address. I'm going to turn off Copilot for a second. The proxy.address will give it the new implementation address. And then we'll just say from account. So this is all we need to do. We just actually, I don't even need this to be a function. I can just do that, right? So this is going to be a transaction that we're going to make on our proxy admin contract. By new implementation, we're going to do proxy2.address. Okay. Now, like I said, depending on if you have an initializer, if you have a proxy admin contract, this function is going to look a little bit different for each kind of difference there. You can check out that upgrade script that I created in that upgrades mix if you want to kind of learn more exactly what these look like. Yeah, that's GitHub Copilot. It's really cool. It's really nice, but it kind of is annoying for demos. Great. So we're going to call this upgrade function. It's going to point to this new box contract that we've deployed. Oh, and then we got to do from account here. Once we've upgraded it, what we can do is we can say proxy box once again equals contract dot from ABI. This time we can do it with box v2. We'll say proxy dot address box v2.abi, and now we can do proxy box dot increment from account. And now if we print proxy box dot retrieve, hopefully I spelled that right. Now if we print proxy box dot retrieve, it should be 1 now, right? So let's go ahead and see if I wrote this good all in one go. And boom, we do indeed see we were to upgrade, right? We saw that. Here's what we did. We stored 77 in our contract, and it didn't have the increment functionality. Then we upgraded it so that it did include our increment functionality with our box v2. We called increment, then we called retrieve, and we were to get 78. So this is the power of doing these upgrades. And we can actually do, let me just add, let's from key. Let's even deploy this to Coven, Brownie run or Rinkby, Brownie run scripts, O1 deploy dash net. Whoops. Rinkaby. Deploy box.deploy. Didn't I just run this? Why are you mad at me? Did I delete something? Alts from key, private key. Box.deploy from account. Oh, you see what I did wrong here? I'm a little confused. Account equals get account. That looks right. Port get account. Sorry, 1 second. Should I just add account the normal way? Accounts.add config. Mad at me for that? Are you mad at me? Writing in scripts. Huh. Oh, my helpful scripts was doing something weird. Sorry. Did you store the private key? Yeah, so it was I'm a dunce. Okay, that's why. Oh, got it. So we have to do networks. It could be, and then we'll just be like, it doesn't matter. We just need ring-b in here. Now this should work fine. Because in the get account function, it looks to see if you have an actual account in here. Let me just make sure I did that right, or an actual network in here. Networks, ring-b, great. And I'm actually going to do one more thing. Actually, no, I'm not. I'm not going to verify. Okay, cool. Let's run. There we go. So we're going to deploy this to the ring-b Etherscan. And the first thing we're deploying, right, is our box. So if we go to the Etherscan, I should just set it up to verify. You know what? Let's just set it up to verify. I'm going to kill it one more time. Sorry. I'm also just going to, for all these deployments, we're just going to do comma, publish source equals true. Remember, this won't work for local. Publish source is true. Deploy, publish source is true. Deploy, publish source is true. Deploy, 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 deploy. Publish source is true. Okay, cool. And so this publish source is true means we're just going to verify all these contracts as we deploy them. You do need an Etherscan API key. Instructions on how to do that are in the README. Same thing with us deploying ring-b. You do need a private key. You do need an RPC URL like Web3 and Fura. All those are in the GitHub repository. If you run into an issue, make an issue on the GitHub repo. Right? Come here, go to issues. Be like, oh, well, look at my test. That's fun. Make a new issue, and I will see it. All right, cool. So we're going to run this one more time. And as this is running, are there any other questions that we have, right? And showing this on Etherscan is really going to solidify what these look like, what these do, and how these all interact with each other. Okay. So we are going to take it is going to take a couple extra seconds for Etherscan to verify our contracts here. But then we can, call functions. We can look at all these contracts and see kind of the code and the functions, and everything kind of comes to life when we do it here. So, are there any questions about what we're doing so far? I know that this is a little bit more advanced stuff here, but I'm hoping people are following along. It looks like a couple of you are following along. When Humanizer said, "Hey, storage is uninitialized," that was spot on. So, as we wait, how's everybody doing? And then maybe we'll just flip back, because we're going to be waiting a couple minutes, because we're deploying, so we got to wait for all the transactions to get mined, and then we're also verifying, so we're going to wait for Etherscan to give us the thumbs up on all of our verifications. So that's also one of my favorite parts of Brownie, is Brownie has this publish source equals true, so you can just deploy and auto get them verified as you deploy, which I think makes a lot of sense, right? Like, why would you not do that? Why would you not have it be auto verified? So yeah, waiting a couple minutes here, and then we'll wrap up with Etherscan. But yeah, if there are no questions here, I guess I'll give you all a thumbs up, and hope everybody's doing well. Hope everyone's enjoying the hackathon. Hope everybody is going to build something really amazing. We got some thumbs up in the chat here. Excellent. There's a lot of downtime when you actually deploy to testnets. This is why I always recommend don't deploy to testnets until that should be like the last thing that you do. Absolutely the last thing that you do, because you have to do this, right? You got to wait all day for these transactions to go through, for these contracts to be verified. This should be the last thing you do. You should make your tests fantastic. Everything should run smoothly on localhost, on a ganache, or on a hard hat chain, and then you can run through. Helpful scripts will be a great thing to see, as integrating your wallet with Web3 Pi will be the first thing that you bump into. Yes. Good point. From the Solidity side, it's pretty straightforward, yeah. So I'll show helpful scripts as we're kind of going through this. It's pretty straightforward. If you want to use a local key, like when you spin up a ganache, so Brownie automatically spins you up a ganache network, and if you want to use one of the free accounts that gets spun up there, you just use like accounts, index or account 0. You can also do this accounts.load thing, which I won't talk about, but this is probably the most secure way to do private key management. But kind of the simplest way is what we're doing here, which we're getting an environment variable from our config. So we have our private key environment variable. If you want, what you can do, you can make a .env. We'll say like private key equals 0x if you're getting it from MetaMask, blah, 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 whatever your private key is. And then just in here, what you would do is you would just say, oops, that's weird. Say .env is .env, right? And that's how you could store your private key in this .env file to get it in there. So we have mine set in the background. So also please don't use the private key that actually has money in it. Please never use a private key that actually has money in it to do your development work. Yeah, just create a new one, right? Create a totally new MetaMask, a totally new browser. Please make sure they're different. As the Solidity side is pretty straightforward. Yep. Oh, that's interesting. You think the Solidity side is pretty straightforward? I was going to say the Solidity side I thought was probably pretty complex, right? These proxies are pretty intense. I guess we're abstracting a lot of the proxy work though by just kind of wrapping them up in this proxy folder. But okay, cool. It looks like everything has gone through. Let's go ahead on chain and see what's actually going on. So first thing, we have box deployed. .etherscan. And if you want to follow along, if you want to play with these, I'll post them in the chat here. So that's the box contract address, right? If we go to contract, right, this is exactly what it looks like. If we go to read contract, what do you think we'll see when we hit retrieve? What do we think we'll see? We'll see 0, right? Because none of the storage gets stored in this, right? We can go ahead and call these like write contracts and stuff, right? Let's even let me just put my fake password in real quick. Okay. So we can even connect to Web3, right? We can call store. We can store like 55 in here. Sure. Oh, whoops! I should have given it more gas. We could store 55 in here. And when we hit read contract, it'll be 55, but the proxy will still say, 78, right? Even if we call on the implementation contract, doesn't matter. The implementation contract is just where your logic is. The storage state doesn't matter at all, right? So now if we refresh, maybe now we see 55 in here. Okay, but let's go back to our proxy admin. Actually, let's just proxy admin. If you all want to see it, proxy admin is going to be here. And in our transaction, we can see we did, we created the proxy admin. We also upgraded our proxy, right? So if we read the contract here, we see we have get proxy admin, get proxy implementation, and owner. So this proxy admin can actually work with many proxies and is one of the other benefits, right? If you have a ton of contracts, if you have a ton of upgradable contracts, you can use the proxy admin to basically work with all of them, right? And then we have write contract. We can change proxy admin, renounce ownership, and this maybe you want to give it to a DAO, right? That's what that would do. We have upgrade and call, which we use when we want to use an initializer. Kind of a little bit less interesting. But then we have our transparent upgradable proxy. Here's where it gets really interesting, and I'll send you the address here as well if you want to play with this. This is the actual proxy. We can see here we called the store function to store 77, and then we also called increment, right? And these were all on this exact same proxy. When we called store, we actually didn't have the increment function, which is really interesting. So now if we look at this, we had a read contract. You'll see, hey, sorry, there are no available contract API methods to read, unable to read contract info. And if we look at write, we don't see any of our box methods here. Etherscan doesn't always know what proxies look like. So because, again, we'd have to put the ABI of the box contract on here, and this Etherscan would have to say, this is a proxy. We're going to read this as if it was a proxy, okay? So if we look at this, it says, sorry, nothing here, but we know that isn't the case. So we could have coded in a retrieve function here, which retrieves from the implementation contract. But instead, what we could just do is we could grab this address, right? Once again, we'll do Brownie console --network rank B. And what we'll do is we'll say contract dot we'll say proxy equals contract dot from ABI. We'll call it box, and we'll do this address that we just got, and we'll say box v2.abi, and now we can do proxy.retrieve. We see 78, right? So even though Etherscan says, hey, this doesn't have any methods you can call, we actually went ahead and called it because we know it's a proxy, right? And we know that there are read variables that it's going to delegate call to. So, so that's pretty much it. Let me know if there are any questions. Like I said, I know this is a little bit heavier subject. This is a little bit more advanced. But this is one of those tools, excuse me. This is one of those tools that can give you the flexibility to make your contracts upgradable and make them really powerful, make them more flexible. Yes, this could potentially be a centralization vector, right? If you are the one to control the upgradability, but as some commenters pointed out, you could give this to your DAO. You could give the proxy admin power to the DAO, and the DAO could be the one to choose whether or not to upgrade. So really cool stuff. Can you have your state variables in Proxy public and access through getter functions? Yes. So technically, they are all getter functions and they are all public right now. It's just Etherscan doesn't know that those are there, right? Because Etherscan's reading the proxy contract, it doesn't see any, any getter functions, any public variables, and it goes, okay, there aren't any here. But we know if when we call the proxy contract, it's going to delegate call to the box contract, right? To the box logic. Yeah, so you could add them, but we know they're actually all there. And oftentimes what Etherscan will do, actually, if we go to like docs.chain.link, go to Ethereum data feeds, do like ETH, do ETH USD. A lot of times what it'll do, if we go to contract, oh wait, okay, never mind. Sometimes it has two buttons called like read contract as proxy, right? So if you see read contract as proxy, that's when it's like, okay, Etherscan knows this is a proxy contract, and then you can do proxy stuff. Sorry, I know I'm not sharing my screen here, but yeah, sometimes Etherscan has that. Cool, great question. Any other questions here? If there are no questions, well, I hope you all have a fantastic hackathon. We're giving you the keys. We're giving you the tools to make some really cool stuff, to make some really amazing projects. Really excited to see what everybody builds. Really excited to get the submissions and see all the cool stuff and get so excited. We have about a little less than a month left now. So we have like, what, 25 days? So there's definitely time to jump in, make the commitment, right? You're here now. You are going to submit, right? If you're here, you're going to submit. Doesn't matter how good or how bad your product is. Definitely you're going to submit, because this is the resume builder. This is how you get better here. You say, I'm going to submit. I'm going to be the one to go in here. And you also get some swag and stuff, right? So you get some swag. You can win some really cool prizes, some educational prizes, some monetary prizes. So thank you, everybody, for being here. I will see you all in the Discord.